Okay, so we have another, or we're going to put the removable discontinuities together with the other concepts that we've already learned here. We learned how to find vertical and horizontal asymptotes, and we've also talked about domain and range briefly. We'll expand on that now. Okay, so for your vertical and horizontal asymptotes, you really do need to factor the numerator and the denominator on your rational function first and see if it can be reduced. So x squared plus x minus 2, we would need things that would multiply to make negative 2 and add to make a positive 1. So that would be x plus 2, x minus 1. And the denominator, x squared minus 3x plus 2, things that will multiply to make a positive 2 and add to make a negative 3. That would be x minus 2, x minus 1. So we can see now these, the numerator and the denominator does have a factor in common. This x minus 1 is in common. So those would cancel. And that would give us a reduced function now of x equals x plus 2 over x minus 2. But again, next to that, we'd have to say that x is not allowed to be whatever value of x would make that factor that canceled out equal 0. So on this one, that would be a 1. Okay, now when I'm finding the vertical asymptote, rather than looking back at the original function and following the same rules that we talked about before, where you just set the denominator equal to 0 and solve it, we have to use the reduced function to do that now. So we're going to be doing x minus 2 equals 0. This is to find that vertical asymptote. Okay, so x minus 2 equals 0, you solve that and you get x equals 2. And remember, your vertical asymptote is a line, so it needs to be written as an equation. Okay, for the horizontal asymptote, you can actually use either the original function or the reduced function. It does not matter. You'll get the same result either way. Remember, for your horizontal asymptote, you have to compare the degrees of the numerator and the denominator to decide which case it was. Now this one, the degree of the numerator, I'm going to use the reduced function. The degree of the numerator is 1. The degree of the denominator is also 1. So this is that second case where your horizontal asymptote is going to be y equals, and then it's the ratio of the leading coefficients. So my leading coefficient on the first one is 1, and on the bottom it's also 1. 1 divided by 1 is 1. Okay, next up, the removable discontinuity. In order to find the removable discontinuity now, the x value is going to be just the x value that we said was not allowed. It's the x that makes the factor that canceled out equal 0. So I'll go ahead and write that down. But I also need the y value that goes along with that. So to do that, I'm going to use this reduced version of the function, and I'm going to put in 1 in place of the x's. And then simplify. So on the top, 1 plus 2 is 3. On the bottom, 1 minus 2 is negative 1. And then 3 divided by negative 1, 3 divided by negative 1 is just negative 3. So my y value there is negative 3. Okay, lastly, we're going to add on domain and range now to this. Now for the domain of these functions, the domain is all the values of x. Sorry, it's any real number except for those values of x that make your denominator of your original function equal 0. So if I went back to the original and I took it and I set it equal to 0, the way to solve that would be to factor it, which we already did once actually. We got x minus 2, x minus 1. And then you set each of those factors equal to 0 and solve. And so I'd say x equals 2 and x equals 1. So these are the values of x that are not allowed because they would make the denominator equal 0, which is what I started with there. So for my domain, I would say x such that x does not equal, and then I would list them in order from least to greatest. So I'd say 1, 2. Now, if you also notice on this, we could do a little bit of a shortcut because we already did all of this work. The values that are in here, this 1 and this 2, are actually the x value from your removable discontinuity and also the value of your vertical asymptote. So you could just take those values and say the domain is all real numbers except for those. For the range, the range is going to be all real numbers again, except for the y value of your horizontal asymptote and the y value of your removable discontinuity. So I'd say y such that y does not equal, and then I would list those values in order from least to greatest. So -3, of course, is smaller, and 1 is larger. Okay, now you try example number 4 and answer the questions on your Google form.